name is Antonio, and I will present my project, which was the antifungal drug development of benzimidazoles. The biological activity of benzimidazoles is important because they inhibit mitosis through binding microtubules in the fungi cells. They have a really high selectivity for fungi cells in order to avoid mitosis. Then the cell replication in fungi cells is not going to take place. In 1933, Good and its collaborators created for the very first time benzimidazole core. They used the diamine 1 and the carboxylic acid 2 in order to obtain it. Thiobendazole is another analog of the benzimidazole compounds. It's an anthelmintic drug for veterinary use, and mammalians show really good tolerance for the drug. The synthesis of this compound was carried out using the amine 4 and the diamine 5 in presence of polyphosphoric acid. A small library of benzimidazoles were made by Smith and Smith-Kline. These three different libraries were made by them. The first, we can see that two of them are amides, and the last one is a carbamate. The carbamates show the best activity. Finally, they developed this compound, and this compound showed to have the best biological activity and therapeutic ratio. After that, it was sold as probendazole. A small library of benzimidazoles were made as well by Camacho and its co-workers. This is the library 8. These compounds are useful against P. falciparum, which is the microorganism which causes malaria. The mechanism by which this library works is the inhibition of beta-hematine. It's a good option against chloroquine resistance showed by some strains of P. falciparum. In the research plan, it was required to develop a small library of benzimidazole analogs. There were developed 4 different routes, as we can see, with 2 different starting materials, having in R1 methyl or nitro groups. Those two substituent groups are really different. It obtained 14 different compounds. As we can see, there are not 18 different compounds because the first route and the second route share the same compounds. It is required as well to measure pKa and log P in order to correlate the structure of the molecules to its biological activity. In the first route, it was used HCl as catalyst, and it was reacted the 2 different diamines with 4 different carboxylic acids. 8 different compounds were obtained, as we can see here. These 8 different compounds were purified by chromatography column and recrystallization. This route was really useful because the only side product produced by it was water, so the purification was rather easy. However, the yields were not, they didn't show any specific pattern, maybe because of the recrystallization. Because of my lack of experience in recrystallization, I should have committed a lot of mistakes. And then the yields are rather poor. The best one is 67% and the lower one is 24%. However, we can see something interesting in the time of reaction. Because in time of reaction, we can see that for this compound, it was required 1 hour, the same as for this one. However, for this compound, having the carboxylic acid, trifluoroacetic acid, it was required 24 hours. It's interesting because the carbonyl group, the carbonyl carbon in that carboxylic acid should be rather reactive towards this diamine. However, the result wasn't like that because it didn't show any important feature. The time of reaction was 24 hours, and even the yield was not the best of all of them. It is interesting also to note that for the compounds obtained using the diamine having nitro group here, the times of reaction were in the range of 18 hours and 27 hours. That means that those reactions require more time. The reason for that could be due to the mechanism. The mechanism of reaction requires the attack of the lone pair of electrons of the diamine into the carbonyl group. This is catalyzed by acid, and then this reaction is going to be favored to the products and not to the starting materials. Okay, establishing that it is required to do this attack at the beginning, we can see that having an electron withdrawer group in this position is going to provoke diminishing in the availability of the lone pair of electrons of the two different amines. That's going to produce a problem for this attack. As we can see in this resonance form of the nitrobenzene, the two nitrogens of the amines, they do not have the lone pair of electrons available for attacking. Maybe that's the reason why the time of reaction for those compounds were higher. The second route that we prepared was using the catalyst DBDMH, which is this one. We can imagine this catalyst as a source of bromine. This bromine is going to increase the reactivity of the orthoester towards the attack of the diamines. The starting materials as well, the starting materials were two phenyldiamines, the same ones as in the past reaction, using CH3 and nitrogen, two different orthoesters. And the products obtained were these four that were the same as in the first route. The purification again was carried out using chromatography column and recrystallization. Again, the yields do not show any important pattern. They are in the range of 54% and 35%. However, it is interesting to note, again, the time of reaction for the compounds made using the nitro group. For these ones, the time of reaction in comparison with the first route was almost the same. 45 minutes for this route, and in the first route, it was required 1 hour. Using nitro group here, it was required just 1 hour, and in the first route, it was required 18 hours in order to carry out the very same reaction. The mechanism by which this reaction is carried out is activating the ethoxide group. The lone pair of electrons in the ethoxide group is going to take the bromine from the catalyst. The catalyst is favored to do that because it has the possibility of having another different resonance forms, thanks to the carbonate here and to the carbonate there. Okay, so what is important to know or to notice is the formation of the oxonium ion. This oxonium ion is going to be easily attacked by the lone pair of electrons of the amine. So maybe that's the reason why this compound, this reaction, took less time than using the first route. It was also done biological assay using the Kirby-Bauer disk diffusion method. We compared these 5 different products that we obtained against fluconazole. All of these compounds were tested against yeast, and fluconazole, of course, since it is the strongest one, we use it in order to compare all our compounds. So the relative activity of the